Friends, good afternoon. And this particular video is about uh, this is for students actually, and the students who are studying in class ninth or 10th. As a teacher, as a facilitator, as a tutor, as a mentor, I had always a firm faith in raising the confidence level of students up to the zenith, up to the apex or top. Uh, According to me, self belief is the thing which is the key to success. And if we talk in the terms of science, then I had always believed that uh, if uh, if your basics are good, then you can get succeed in every endeavor in your life and any endeavor in your life, and you can crack any competitive exam being a student. For students of class ninth and 10th, I'm just going to give the example of two particular topics. For example, mole concept. I'm talking about science right now, and in particular, I'm going to talk about chemistry. So mole concept is a very basic concept about which every student of class ninth and 10th should be well aware. So let's start with mole concept. What do you mean by mole? Mole is a fundamental unit. All of you must be well aware with this term, fundamental unit. Fundamental units are the units of fundamental physical quantities like length, mass, time, etc. So mole, length, mass, time, and the units of length, mass, time is meter, kilogram, seconds, and so on. So mole is also a fundamental unit which is used to measure the amount of substance. Okay, in the language of chemistry, whatever you witness, whatever you see in this surrounding, that comes under the category of substance or matter. Okay, so mole is the fundamental unit which is used to measure the amount of substance. Now, for an atom, if we have to calculate the number of mole, what should be our approach? If the weight of an atom is given, then first of all, we have to make sure that that particular weight should be in gram itself. So weight of an atom in gram upon atomic weight of that particular atom. And then in case of a molecule or a compound, what will be the number of moles? Number of moles will be equal to weight of a molecule in gram upon molecular weight. Weight of a compound in gram upon molecular weight. For example, if we have to calculate the number of moles in 24.5 gram of H2SO4, then how can we approach? Since the weight is 24.5, that should be divided by molecular weight. H2SO4's molecular weight is 98. So 24.5 upon 98, when you will simplify it, you will get 0.25. So 0.25 is the number of moles in case of H2SO4. Third case, third formula, when the when instead of weight of an atom or molecule, suppose number of moles, number of instead of weight of atom or molecule, suppose if number of atoms or number of molecules or number of ions are given, then we have to divide it by Avogadro number. So number of third formula for number of moles, that is equal to number of atoms slash number of molecules slash number of ions divided by Avogadro number, which is equal to 6.022 into 10 power 23. And the fourth formula to calculate the number of moles is this formula is applicable in case of gases. So number of moles in case of gases, that is equal to volume of gases in liter upon standard molar volume. The value of standard molar volume is 22.4 liter. For example, if I ask you to calculate the number of moles in case of 2.8 liters of a gas, so what will you do? 2.8 divided by 22.4, 1 by 8, and it will be equal to 0.125 moles. So I think all of you must have got the concept of mole concept, and all of you will be able to calculate the number of moles quite easily now. The second topic regarding which I want to talk is atomic structure a little bit. Atomic structure is a topic about which every student should be well aware. And if a student is studying in class 11th and he is going to start physical chemistry and all, first of all, according to me, in the inorganic chemistry, he should be He should be well known. He should be well aware about this topic, about this particular topic. So, what actually an atom is? An atom is the smallest particle of a substance or matter, which is unbreakable and indivisible. An atom is the smallest particle of a substance which takes part in the chemical reaction and can form molecule. Atom is unbreakable, okay? Atom is indivisible, and it takes part in the chemical reaction and can form a molecule. This theory was given by Mr. Dalton, but later on, many scientists came. For example, Mr. J.J. Thomson, Sir J.J. Thomson, who was the discoverer of electron as well. Sir J.J. Thomson told that atom is not indivisible or unbreakable. Atom is atom is full of charges, and atom is just like a sphere in which positive charge is spreaded everywhere and negative charge is embedded here and there. So he compared his model with a watermelon, and he told that uh, just like in a watermelon, there is a red edible part. So red edible part can be compared with the positive charge of an atom, and the black seeds that can be compared with those black seeds can be compared with the negative charge. Positive charge, that was proton. Negative charge further, that was known as electron. Okay. After Sir J.J. Thomson, Rutherford came, and he did a very big experiment in the aspect of atomic structure. The name of his experiment was alpha particle scattering experiment. What he did actually, he took a thin gold foil. Why did he chose a thin gold foil? Actually, he wanted to make a thin sheet as possible. That's why he chose a thin gold foil, and he compelled alpha particles to pass through it. And what did he observe then? Most of the alpha particles cross the gold foil as if the whole of an atom is an empty space. Some of the alpha particles, after striking on the gold foil, deflected from its path, and very few, one out of 12,000 alpha rays, it returned back to its original path. Okay, so as if it must have collided with a rigid part. So that Rutherford concluded that uh, in the center part of an atom, nucleus lie. In the nucleus, nucleons exist, and nucleons means protons and neutrons, and electrons continuously revolve around the nucleus. Electrons continuously revolve around the nucleus. Uh, but there were some drawbacks in Rutherford's model as well. Rutherford told that electrons are continuously revolving around the nucleus. According to the principle of electrodynamics, any moving charge particle, it loses its energy. Since electron is also a charged particle, it's it has negatively charged, it has negative charge, so it will also lose its energy while revolving around the nucleus. And after losing its energy, one stage will come when electron will become completely energyless and it will fall into the nucleus. So Rutherford's model also could not explain the stability of an atom, and it failed. What were the drawbacks of Thomson's model, which I have discussed earlier? Actually, according to Sir J.J. Thomson, most of the part of an atom is positively charged. When Rutherford experimented with a thin gold foil and he passed alpha particles through thin gold foil, since alpha particles were positively charged, and earlier Thomson told that most part of an atom is positively charged. So positive charge of alpha particles after striking on the gold foil, most of the alpha particles should have repelled instead of crossing the gold foil. But since most of the alpha particles cross the gold foil, so Thomson's model also failed. Just because, according to Thomson's model, there was a positive charge spreaded all around the sphere, all around the atom. So, uh, after Rutherford, so Niels Bohr came. He told that electron, no doubt, it revolves around the nucleus, but not everywhere. It revolves in a fixed circular orbit. That fixed circular orbit is known as shells or energy level. And the maximum number of electrons which can revolve in shell or energy level is 2n square, where small n is the number of shell. Number of shell, uh, K, L, M, N, O, P as well. But for class 10 students, they have to study KLMN only. These four shells. Shells are known as energy levels, shells are known as orbits as well. Uh, Niels Bohr told that while revolving in these shells, electrons do not lose their energy. And if they want, then by losing their energy up to an extent, they can change their shell. They can change their shell. They can uh, they can jump from L shell to K shell, or M to L, or N to M. So uh, about Borbori model and many other things, many advanced concepts in atomic structure. For example, Pauli's exclusion principle, Hund's rule, Avba principle, and so many other things we will study in the next video. Last but not the least, I want to tell about the orbital. What do you mean by orbital? Orbital is a tri-dimensional space around the nucleus in which the probability of finding moving electrons is maximum. Orbital is a tri-dimensional area around the nucleus where the probability of finding the moving electrons is maximum. And that's it for today. And we will meet in the next video where we will learn many concepts about atomic structure. Thank you so much. Please, if you like this video, then share it and subscribe my channel as well. Thank you.